Shanghai, June 25th, 2026. A woman named He Tingbo walks to a podium inside a convention hall full of the world's sharpest semiconductor engineers. The room goes quiet. And then she tells them that Moore's Law, the 60-year-old principle every chip on Earth has lived by, is over, and that China has something to replace it. Within hours, markets in Shanghai are moving. Engineers in Silicon Valley are pulling up her slides. Inside boardrooms at Intel, TSMC, and Nvidia, the same question is forming. Is this real? 60 years ago, a man named Gordon Moore noticed something. Every 2 years, roughly, the number of transistors you could fit onto a chip doubled. More transistors meant more power, faster computers, smarter phones, sharper weapons, deeper artificial intelligence. The rule, he described, became the engine of the digital age. Every device you have ever touched, every message ever sent, every war ever won by technology, all of it built on that one compounding insight. Make the transistor smaller, do it again, never stop. But by 2026, transistors have gotten so small they are measured in atoms. There is almost no physical room left. The law that built the world is running out of road. And every major chipmaker on Earth has known it quietly for years. That is the problem Huawei just claimed to solve. What Huawei calls the TAU scaling law asks a different question entirely. Not how small can we make a transistor, but how fast can we move information through one. TAU is the Greek letter for time, and Huawei's engineers argue that the real bottleneck isn't transistor size. It's the time signals take to travel between components. Cut that time, and performance improves, regardless of the manufacturing node, regardless of whether you have access to the world's most advanced equipment. The practical implementation is called logic folding. Imagine every chip ever made as a city laid out on flat ground. Every block, every signal path, every connection spread across a single two-dimensional plane. Signals travel long horizontal distances. Energy is wasted. Speed plateaus. Logic folding builds upward instead. It stacks traditional circuit layers into three-dimensional vertical columns, the difference between a suburb and a skyscraper. Signals travel shorter distances. Latency drops. Density climbs. Huawei has not just sketched this on paper. Over the past 6 years, it has quietly designed and mass-produced 381 chips built on tau scaling principles across smartphones, artificial intelligence computing, and industrial systems. The Kirin 2026 chip, set to launch this autumn, will be the first commercial product to carry the full logic folding architecture. Early engineering data is striking, a 55% increase in transistor density over the previous generation, with 41% lower power consumption achieved without moving to a more advanced manufacturing process. Not a better fab, a better idea. The target Huawei has publicly committed to is this: by 2031, chips designed under the tau scaling law will achieve transistor density equivalent to a 1.4 nanometer process. Taiwan's TSMC, the most advanced chipmaker on the planet, currently manufactures at 2 nanometers and has planned 1.4 nanometer mass production for 2028. If Huawei hits 2031, China would be approximately 3 years behind the global frontier. 3 years is a dramatically different story from the 5 to 7 year gap that analysts were citing just recently. He Hui, director of semiconductor research at Omdia, described tau scaling as a credible way to extract more performance when leading-edge lithography is constrained. In an industry that speaks mostly in qualified sentences, that assessment carries weight. 4 days before He Tingbo took that podium in Shanghai, Nvidia CEO Jensen Huang sat for an interview and said something almost no one expected from the man running the world's most valuable chip company. He said Nvidia had largely conceded China's artificial intelligence chip market to Huawei. Not losing, not trailing, conceded. Past tense. The numbers underneath that word are staggering. Before US export controls began tightening in 2022, China represented somewhere between 20 and 25% of Nvidia's data center revenue. By 2026, that figure had collapsed to roughly 9% of the company's total. Bernstein Research projects that Huawei's share of China's artificial intelligence chip market will reach approximately 60% by year's end, up from near zero 3 years ago. ByteDance, Baidu, and Alibaba, three of the largest technology companies on Earth, have all publicly confirmed they are deploying Huawei's Ascend chips at scale for large language model training. The companies that once filled Nvidia's order books are now building their entire artificial intelligence infrastructure around Chinese silicon. That shift did not happen because Huawei's chips are definitively better. It happened because the alternative vanished. When Washington banned Nvidia's most advanced chips from Chinese sale, the H100, then the modified H20 in April 2025, triggering a $4.5 billion inventory write-down, Chinese firms had no choice but to build something at home. They built Huawei. The backfire. Washington's logic was clean. Deny China access to cutting-edge chips and chip-making equipment. Slow its progress in artificial intelligence. Maintain America's lead. The campaign started in October 2022 under the Biden administration, tightened repeatedly into 2025, and included export blacklists, tariff walls, and diplomatic pressure on allies. It was one of the most aggressive technology restriction campaigns in American history. Here is what actually happened. China didn't slow down, it accelerated. The Center for Strategic and International Studies concluded that while export controls created genuine short-term disruption, they simultaneously forced China to build the very capabilities Washington was trying to prevent. Huawei's own rotating chairman, Xu Ji-jun, said it plainly. If the United States hadn't forced this, China wouldn't have done something like this. The Information Technology and Innovation Foundation published a blunt assessment in June 2026. U.S. chip controls have accelerated China's push for self-sufficiency and strengthened competing artificial intelligence ecosystems. The wall built to contain China may have funded the research that built the ladder over it. The global semiconductor market is heading toward roughly $917 billion in 2026. China's artificial intelligence chip market alone is projected to reach $67 billion by 2030, with none of that business going to American companies at the scale it once did. China already accounts for roughly 24% of the total global semiconductor market. Its manufacturing capacity for chips on mainstream process nodes is projected to reach 42% of global output by 2028. The Tau scaling law still needs independent validation. The Kirin 2026 chip will reach real testers and real owners by winter, and the numbers it posts in the field, not on a slide, not in a press release, and not in controlled lab conditions, will be the first honest test of whether these promises hold. Announcements that sound revolutionary have arrived underwhelming before. Engineers are right to hold judgment until the data exists. But some things are already settled. Jensen Huang has conceded China's artificial intelligence chip market in public. 381 chips have already been built on Tau scaling principles in mass production. And a company that American policy was specifically designed to contain just stood at one of the world's most respected engineering conferences and proposed replacing a 60-year law that America invented. The chip war between the United States and China was designed to have one outcome: the side with the best equipment wins. No one planned for the possibility that the side without the equipment would decide to change the game entirely. If you liked this video, don't forget to like and subscribe, and click the next video on your screen for another interesting breakdown on the latest technology. There's a lot more coming.